Okay guys, welcome to Packet Tracer 6.2.3.6, configuring multi-area OSPFv2. In this activity, you will configure multi-area OSPFv2. The network is already connected and interfaces are configured with IPv4 addressing. Your job is to enable multi-area OSPFv2, verify connectivity, and examine the operation of multi-area OSPFv2. Okay, so part 1, configure OSPFv2 on router 1 with a process ID of 1 and a router ID of 1.1.1.1. Okay, so router 1, command line, router OSPF process ID 1, router ID 1.1.1.1. Now, step 2, advertise each directly connected network in OSPFv2 on router 1. Configure each network in OSPFv2 assigning areas according to the addressing table. Okay, so this is the first packet tracer we've done with multi-area OSPF. Looks like area 0 is this interface and this interface. And then area 1 is just here. And area 2 is just here. It's a little different than how they show it in the text, but anyway, so it's real simple. We're just going to use these network commands. Network 10.1.1.0 0.0.255 area 1, and then the same command for network 10.1.2.0, also area 1, and then we're going to do network 192.168.10.0 area 0. There we go. So let's save that config. The next step is repeat the steps above for router 2 and router 3 using a router ID of 2.2.2.2 and 3.3.3.3 respectively. So router 2 is only a backbone router. It's only in area 0. So this is going to be a lot easier. Well, it's really the same thing. It's no easier. Router OSPF process ID of 1, router ID 2.2.2.2, and then we're going to advertise our network. So network 10.2.1.0 with a wildcard of 0.0.0.255, and we are area 0, and then network 192.168.10.0 with a wildcard of 0.0.0.3, also area 0, and then network 192.168.10. I believe it's going to be .4. Okay, there we go. Network 192.168.10.4 because 255, 255, 255, 252 is a prefix length of /30. We've got 2 bits, which gives us a total of 4 addresses, which gives us 10.4 being the next network address. It's generally in these packet tracers one below whatever the IP address is on the lowest IP address in that subnet on an interface. But anyway, just best to make sure. 10.4 again a 0.0.0.3 and also area 0. Okay, and then on to router 3, do the same thing. Enable, configure terminal, router OSPF1 router ID 3.3.3.3, and then these networks are area 2 and area 0, so we're going to start with network 192.168.2.0, 0.0.0.255, area 2, excuse me, and then network 192.168.1.0, 255. Oops, what did we miss? Area 2. Yep, that's the important part. And then network 192.168.10.4, I believe is what we decided it was. And also going to be area 2. Oh, first we have to do our wildcard mask. No, and that's going to be area 0, I'm sorry. Okay. Sorry guys, I was just thinking about how it drives me crazy that they don't do the no IP domain lookup command. And these routers, even though it's the first thing they have you do in all the labs. So useful. Anyway, probably too late for that in this one. Okay, so now we're going to, even though we're at 80 out of 80 completion, we're going to continue on with these steps. Verify connectivity to each of the OSPFv2 areas. From router 1, ping each of the following remote devices in area 2. So, router 1, ping 192.168.1.2. Yay, that worked. Ping 192.168.2.2. Great, that worked too. Ping 10.2.1.2. That also worked. Step 2, use show commands to examine the current OSPF operations. Use the following commands to gather information about your OSPFv2 multi-area implementation. So, show IP protocols. Looks like we got it going. So you can see here we've got our 3, and then we've got 4.4.4.4, 5.5.5.5, and 9.9.9, and those are going to be out here in these other networks. Okay, alright, so let's do show IP route. Oops. Alright, so we've got a lot of OSPF routes propagated here. See, we have IA, which means OSPF inter area, which means it's a different area than, area 1, area 2. If those talk to each other, that's an IA route. Okay, great. Show IP OSPF database. Okay, so here we have some reflection questions. Your teacher may or may not require these. If so, they're pretty simple. You can get all these answers from these places. Which routers are internal routers? You should just know that one from looking at the text. You can go up here and see that looks like router 2 is the only internal router because it's the only one that's not in 2 areas. Which routers are backbone routers? Well, strangely enough, router 2 is a backbone router. Oh, so is router 1 and so is router 3 because they're all in the backbone. Which routers are area border routers? So router 2 is not because it's internal. It's going to be router 1, router 3 because it's an area border. I mean, it borders between 2 areas. So anyway, you guys can answer those questions for yourselves. See you on the next packet tracer.